Hereby, I open this academic ceremony in which Xanthate Duggirala will defend the academic thesis, The Role of Prediction and Attention in Phantom Voice Perception. May I invite you to present a summary of your study and the conclusions of your thesis?
Highly esteemed Pro-Rector, members of the opposition, supervisors, colleagues, family and friends. Thank you all for joining me here in person or online for the defense of my dissertation titled The Role of Prediction and Attention in Phantom Voice Perception. In the next 15 minutes, I will briefly explain the research work included in this dissertation, specifically focusing on the primary concepts, methods, and the main findings. We, or rather our brain, makes constant predictions in our day-to-day lives. For example, when we are driving and we are at a traffic signal with an orange light on, we know, based on our previous knowledge, that this light is going to turn to red, which means, and based on this prediction, we make a decision to drive through or stop and wait. Another example, similarly, while playing a sport. For example, while playing table tennis, we plan our shot based on the predictions generated by the body postures of the opponent, the way they are handling their racket, their eye gaze, and on the previous knowledge based on playing with this person. A more specific example that probably we all are familiar with is that of tickling. Why can't we tickle ourselves? If we try to tickle ourselves, we do not feel ticklish. However, if somebody else tries to tickle us, we do feel ticklish. This is because when we are trying to tickle ourselves, our brain already knows that our hand is going to move and make us tickle, which means that we predict the consequence of this motor movement, and our brain cancels the sensation, and we don't feel ticklish. However, when somebody else is going to tickle to us, we don't have any predictions. We do not know when, how, where this person is going to make a motor movement with the hand and is going to tickle us. Therefore, we do feel ticklish. Now let us extend this example and go to the auditory domain. Our own voice is the most important voice that we hear all the time in our daily communication. However, it grabs minimal attention and we are not aware of it all the time. However, if there are unpredicted or unexpected changes in our voice, for example, when we have a cold or when we are hungover, we pay more attention to our own voice. Why do we feel these differences? It is because, for example, when we are speaking, one part of the brain tells the other part of the brain, which is the auditory brain area, that you're going to make a motor movement with your mouth and you're going to hear a voice, which means that this is predictable. Speaking is a self-generated action. It being predictable grabs less attention, and there is less brain activity in the auditory brain area. On the other hand, when we are listening to a recorded voice of our own, or if someone else is speaking to us, there are no predictions generated, which means listening is an externally generated action. It is unpredictable. Therefore, it garners more attentional resources and ultimately leads to more activity in the auditory brain area. We measure these brain signals during speaking and listening using a method called electroencephalography, which translates to measuring electrical signals of the brain. And this looks something like this. We place a cap with multiple electrodes on it, and the signal looks something that is on the screen. Let's zoom in on a tiny part of this signal. On the x-axis, you see a time changing in milliseconds from 0 to 200. On the y-axis is the strength of the brain signal in microvolts. So suppose if somebody is speaking at time point 0, the brain signal will look like this. and if somebody is listening to their own recorded voice at time point 0, the brain signal will look like this. What we have to pay attention to is the change in this brain voltage at 100 milliseconds for the both signals. If you notice, the blue line is suppressed compared to the red line, which means that the brain activity in the auditory brain area is suppressed when voice is self-generated compared to when it is externally generated. And the difference between these two signals is called the N100 suppression effect. Now, a relevant question comes, why do some people hear voices in the absence of an external source? Hallucinations, by definition, are perceptions with no corresponding external source. One of the main concepts or theories states that the inability to differentiate self-generated voice from an externally generated one may lead to the experience of hallucinations. Empirical studies have supported this theory by showing that brain activity in the auditory brain area is not different for self-generated, when somebody is speaking, for example, compared to externally generated, when somebody is listening to their own voice, for example. Which means there is no N100 suppression effect. Studies have also reported that it's not just schizophrenia patients that hear voices, but also individuals from the general population that hear voices and experience hallucinations. Which means that we may lie on this continuum of low to high hallucination proneness, where on one end are individuals who do not hear voices, followed by those who do hear voices but are not patients, meaning non-clinical, and on the other end are clinical voice hearers, example, schizophrenia patients. While there are a lot of commonality and similarity in terms of phenomenology of the voices experienced by non-clinical voice hearers and clinical voice hearers, there are also many differences. One of the main differences is the emotional quality of the voices. In non-clinical voice hearers, the emotional quality of the voice is either neutral or positive, whereas in the clinical voice hearers, the emotional quality of the voice is negative and derogatory. This leads to a negative effect on their daily life functioning. In the non-clinical voice hearers, the frequency of the voices is less and does not cause distress, but it is opposite in the clinical voice hearers, meaning the voices are more frequent and are distressful. Similarly, going to the next point, non-clinical voice hearers can control their voices, and clinical voice hearers, these voices are not controllable. And lastly, because of these points, clinical voice hearers need psychiatric care as opposite to the non-clinical voice hearers. Let's see some examples of these voices. For example, this individual reports that they hear their dead grandparents' voice. They say, almost every morning while I do my housework, I have a pleasant conversation with my dead grandmother. I talk to her and quite regularly hear her voice actually aloud. Then there is another individual who reports, my voice told me that the back wheel of my bike was wobbly. I should check it. I'm thankful for the warning. Another individual reports hearing the voice of God. This is all examples of non-clinical voice hearers. Lastly, clinical voice hearers experience voices that tell them that they are coming for them and that they are worthless, meaning that these voices are negative and derogatory. Now, how do we translate these concepts into lab measurements? We recruit participants, we interview them, and we ask them to do certain questionnaires. Primarily to measure hallucination proneness, we use the questionnaire called Lonnie-Slade Hallucination Scale. Particularly, participants are asked to what extent these statements apply to you. And they have to rate with a 5-point Likert scale, starting from certainly not applicable to me to definitely applies to me. A common example or two examples from this questionnaire are, I often hear a voice speaking to my thoughts aloud. I have been troubled by hearing voices in my head. After the session, we invite the participants to record their own voices, for example, ah vocalizations. This may sound something like that. 100% neutral ah vocalization, and 100% emotional and here angry vocalization. To create the final stimuli, we morph these two voices and create a continuum of self-voice for each participant, changing from 100% neutral to 100% angry. So here is an example of 100% neutral. Moving on. And lastly, 100% angry. Why do we do this? It is not just the emotional quality of the voice that is changing from one end to the other. It is also that the certainty or the ambiguity in the self-voice changing for each participant. So, for the endpoints, the voices are not manipulated, meaning that these voices are most certain in terms of perception. However, the middle voices are a mix of the two endpoints, meaning that these are ambiguous in terms of perception. Why we do this? We do this to probe both prediction, which should be high for both the endpoints because they are expected, they are certain, but low for the middle voices because they are unexpected and ambiguous. Similarly, attention does the opposite. So for the endpoints, attention is low, meaning expected voices and certain voices, but attention is high as soon as you hear an ambiguous voice, for example, when your voice is cold or sounding weird. Now, after this, participants perform a task called motor auditory task while their EEG signals or brain signals are being measured. There are two conditions in this task: self-generated, which is equivalent to talking, and externally generated, which is equivalent to passive listening. In the first condition, participants press a button to elicit one of the 5 voices, whereas in the second condition, participants passively listen to one of these voices. What did we find? One of the main findings that we found was that we replicated the N100 suppression effect, which means that the auditory brain area for all the participants, irrespective of the emotional quality or hallucination proneness, was suppressed compared to the brain activity during the externally generated condition. Right? So for self-generated, it is the blue line, and for the externally generated, it is the red line. On the right, you see the same difference, which is the N100 suppression effect between the blue and the red line represented with a bar graph. Second, the effect of emotional voice quality. What we expected was this U shape of N100 suppression effect, changing from normal suppression effect for 100% neutral voice because it is certain and expected. Then it goes in the reverse direction, meaning reversed suppression effect for ambiguous, uncertain, unexpected voice, and then going back to the normal suppression effect, which is the 100% angry. However, we did not find any effect of emotional voice quality on N100 suppression effect. This could be the reason because participants may not have perceived perceptual differences between the 5 voices. They may have been surprised, but it was not significantly different. They still recognized their voice. Lastly, the effect of hallucination proneness. What we expected from previous empirical studies was that non-voice hearers will show a normal suppression effect. This effect will reverse in non-clinical voice hearers. And lastly, there would be no suppression effect for clinical voice hearers. These are based on different studies that compare different groups of voice hearers compared to the healthy controls. What we found was something like this. We did not do a group analysis. We did a continuum analysis, but this is just to show the differences of the endpoints. What we found was change in N100 suppression effect as the hallucination proneness increased. Specifically, the suppression effect reversed or reduced with high hallucination-prone individuals. to conclude, prediction and attention are interrelated in voice production and perception, as shown by the N100 suppression effect. And the current findings support continuum hypothesis, as suppression effect changes with increase in hallucination proneness. And with this, I would like to thank you all for your attention. And herewith, I give the word back to the prorector.
Thank you very much. Thank you for your presentation. The opposition will now be opened by Professor Jansma, Professor of Cognitive Neuroscience of Language at this university, and she was chair of the assessment committee.
Thank you, Prorector. Dear candidate, first let me start with congratulating you and also your supervisors with this great work. I really read your thesis with great interest, and I learned a lot, and it was well written and also published in international journals. And I think given your background coming from engineering, moving into neuroscience and neuropsychology, I think is a raw model of interdisciplinary backgrounds resulting in something beautiful. So I think you can be very proud. But I also have questions. I actually have a lot of questions, but I would like to relate to chapter 4 and actually the results, because you nicely already just gave us the gist about that. But when I look into figure 4, and I just, it's on page 110, it's printed a bit small, and I realize probably I'm getting older or so, but I sense that there is a suppression effect, but only in one of the conditions. So now I'm focusing only on the N100. And when you look into the blue versus red curves, then actually all are aligned beautifully except for the 40-60 condition, where I actually see the suppression effect. So I just wonder what goes on there. So you say you could replicate the main effect, it's there, but when I look into the data, it's just in one of the stimuli conditions, and I just would like to hear your thoughts about that.
Highly esteemed opponent, thank you for your compliments and questions. Indeed, visually it looks as if there is no suppression effect because also the graph is small. However, based on the statistics, and this was a bit different from the traditional ANOVAs that we usually do, because our question was to look into the continuum effect and use hallucination proneness as a continuous variable. We did linear mixed modeling, and there we found that there is a significant suppression effect with more negative peak for the externally generated voices. However, this was not specific to one voice, but this was regardless of the emotional voice quality, which could be seen as the main effect of condition.
Yeah. So I get that point, but then still I wonder, so if I look into waves and I can't see it by eye, I get a bit nervous, probably over nervous or so, and I was wondering whether there's something else going on that you have not discussed in much detail, and I just want to hear your view, and that relates to the stimuli. So you described that you morphed the stimuli. You also mentioned the software by Kawahara, the tandem straight software, where you. And I would just wonder what did you do? How did you morph emotion into the stimuli, and how would it change the spectrogram of the acoustic signature of the stimuli?
Right. To answer the first question once again, if we just average all 5 waveforms, we do see something that looks like a suppression effect, although it is very small. But this we did recently for the reviewers, so we know that there is visually some suppression effect. And coming back to the second question, we morphed R and O vocalizations in this chapter, which spanned from 100% neutral and 100% angry. So we give 2 inputs to the software and ask the software to morph. It basically extracts the fundamental frequency of both the voices, and then where there is
Sorry to interrupt. So basically, then you alter just the fundamental frequency, or you also alter the formant 1 or formant 2 frequencies, for example, of the vowel or the consonant?
I think it automatically gets altered, but I don't give the instructions per se to alter specifically frequency.
And I'm asking because so I was wondering what happens when you alter this way. And I came across this study by Nietzsche, like I saw that you didn't cite it, but these people actually ask what is in the efference copy, which relates to the prediction part of your thesis. So they believed, yes, there is an efference copy, but they wanted to ask, is this more the prototype of something that I'm speaking, or is this the actual realization of what I'm speaking? And what they found they asked people to repeat a vowel or a syllable 200 times, and then on an F1, F2, 2D plot, they defined the prototype of the speaker and peripheral realizations. And they clearly could show, based on N1 suppression, that actually it seems to be the prototype that is the efference copy. So you always send from the motor to temporal lobe a prototype. Now my question would be, if you do all the morphing, what is a prototype of an R and O in your study?
That is a good question. Thank you. I wouldn't know the right answer. I don't think the statistics or the analysis would have answered this.
Mm-hmm. But it's probably something to discuss over coffee later on. Huh?
Absolutely.
Yeah. Thanks, but you were very convincing on that you found a suppression in general. Thanks a lot. Yes, I give the word back to the prorector.
Thank you very much. The next opponent is Professor Schröger, Professor of Cognitive and Biological Psychology, University of Leipzig, and he is present online.
Yeah, thank you, Prorector. Can you all hear me?
Yes.
Okay, thank you. So now, thank you. So, dear candidates, I am very proud and very happy to serve as an opponent in your defense. And as we have now 7 minutes only for my questions and your answers, I suggest that we forget about the fact that I appreciate your thesis a lot and that I very much liked your seminal presentation of your work, but I take my task as an opponent serious and give you hopefully very challenging questions. So the first of my 3 questions relates to the chapters number 4, 5, and 6, especially parts of the methods and appendix sections. And if you have a look at those parts, when you describe how your EEG data were filtered, you give the limits of the bandpass filters, but give no information about which filters you use and what the exact filter parameters were. There are scientists, in brackets, I do not belong to them, but still who argue that this type of information is very important because, as you know, as an engineer, that the filter characteristics can have a great impact on the morphology of the waves you are filtering. So why did you not record the characteristics? And maybe you had good reasons for doing that, or could you possibly provide what were the basics of your filters you have applied?
Highly esteemed opponent, thank you for your compliments and questions. To answer your question, we used a software called Let's Wave, and some of them, we made a script that works on MATLAB and uses Let's Wave to analyze the EEG data in chapters 4, 5, and 6. The filtering that we used, the temporal filtering that we used in all 3 chapters was bandpass, Butterworth filtering. In chapters 4 and 5, the range was 1 to 30 hertz, whereas in chapter 6, it was 0.5 to 30 hertz. Beyond that, I am unfortunately unaware of the details of the Butterworth filter. Yep.
Okay, thank you for this short but concise answer. Now to the second question. It results also to chapters 4, 5, and 6, and it relates to the presentation of results, and it partly overlaps with the previous comment of the previous opponent. In my opinion, you did show too few ERP waves. You only showed the grand average ERPs as waves, but not the critical comparisons between the critical factors and factor levels, or the different ERPs for these comparisons. And well, I'm old-fashioned, and maybe nowadays people do not show this any longer, but I would feel more comfortable when seeing the complete waveform and not only the average amplitudes, or maybe only the outcome of the models and the modeled data. So could you shortly explain why you did choose this approach and what I might have possibly missed by not showing the full ERPs?
Just to reiterate the question so that I understand this more precisely, you're asking why did we choose the statistical analysis that we did?
Sorry to interrupt. I do not complain about the statistical analysis, but I mildly complain about the fact that you only show the grand average ERPs, but not the ERPs separately for the groups you used and separately for the factors you manipulated in the experiment. I think this would have yielded important information in order to being able to better see how the statistic was done and how the average amplitudes for the different factor levels did arise.
Indeed. For different groups, meaning low hallucination proneness and high hallucination prone individuals, for example. Right. So since the beginning, we wanted to avoid dividing the group or the sample size into two groups because we wanted to go along the lines of the continuum hypothesis and use the hallucination proneness variable as a continuous variable. And that is one reason that we did not divide the sample into two groups. And the particular statistical method helps us answer that question using HP as a continuous variable. However, if we want to see the differences in the two groups, the graphs on page number 113, figure number 3, for example, for chapter 4, gives us an idea of how N1 suppression effect could be different at the endpoints. And we particularly see that for at least the first 4, the self-generated voice condition, the N1, increases as we move higher in the hallucination proneness scale. And we can see that the suppression effect sort of reverses or reduces as HP increases. So that gives us an idea that if we may have divided it into two groups, probably with a median split, we may see different N1 suppression effect irrespective of the voices or the voice stimuli.
Yeah, so thank you. I think I got the point. I think also the figure, for example, presented at page 113 is very helpful to support your point. But I still, well, I think in your short introduction to your thesis, you also used in the final slide for the results a simplified variant where you have only the healthy controls, and you summarized then the patient group in order to make the distinction more clear. And I think for the ERPs, this would have been possible and helpful as well. But I think we almost ran out of time. My last comment is very general and points to the maybe to the whole thesis. And the question is that you presented perception mainly as the result of a predictive machinery which helps in correctly interpreting the incoming stimulus information with respect to what you know already about the world. But isn't it so that the field of perception psychology could survive well for decades without this kind of predictive processing background? There are several theories, for example, feature detection theories that explain perception as a hierarchy of filters or feature detectors applied to the sensory information, which finally then results in an object which can then be perceived as a representation of the outer world. Other examples are, for example, recognition by components models or directive perception theories. So there's a lot in the world of perception which can live without prediction. Why did you confine your results to prediction processing only? Or what do you think can be the role of these non-predictive theories for the future, given your results, which are very consistent to the predictive processing theories?
Please keep the answer short.
I have lost the train of my thoughts. I'm sorry. Why did I confer to using predictive processing within the chapters 4 to 6? In the chapters 4 to 6, we were particularly using a particular paradigm that looks into predictive processing using self-generation and external generation of own voice, and that was one of the primary concepts within this paradigm. And that is one of the reasons. But I think I'm missing the point that you're trying to make. I'm sorry, I have lost the train of my thoughts at the moment.
No problem. Possibly the second round at the end of the defense. And if not, I fully accept your short answer because I use the very same framework that you use.
Okay, thank you very much. The opposition will now be continued by Professor Pourtois, Professor of Biological Psychology, University of Ghent, also a member of the assessment committee, and he's also with us online.
Thank you very much. I hope you can hear me well over there in Maastricht. Like my colleagues or the other opponents, dear candidate, I would like to congratulate you on your work, but also your presentation earlier today, which I found very clear and also bringing clear conclusions about your work, which is quite impressive in terms of size and extent. With those words, then, I would like also to ask you a couple of questions, and I'm going to start off with a few methodological questions. When I read your thesis, I found it really nice, this task you use, or this paradigm you use, namely the motor auditory task where people push a button and then they can hear a voice. But if the goal is really to look at hallucinations, I was wondering why you didn't use morphing between, let's say, noise and voice, really to manipulate voice quality at a different level, right? Because you could imagine that people who have hallucinations would push a button when they hear noise and would treat this as a voice signal, which would be, I think, more direct evidence for hallucination. So I wanted to ask you why you didn't choose this more straightforward approach to begin with.
Highly esteemed opponent, thank you for your compliments and questions. Indeed, that is a very interesting idea to use and morph voice with noise. And we would have probably seen a difference between high and low hallucination-prone individuals, because high hallucination-prone individuals are or tend to see something salient in an irrelevant stimuli, for example. So they would have probably perceived something like a voice in a noisy stimuli. But these differences have been studied in previous literature, one. Second, we wanted to specifically probe the differences in, for example, non-clinical voice hearers and clinical voice hearers by using the emotional quality of their own voice. Initially, the idea was to recruit not just non-voice hearers, but also non-clinical voice hearers and clinical voice hearers, so that we can see in the whole spectrum how changes in self-voice in terms of emotion that is of importance to clinical and non-clinical voice hearing. For example, negative emotion, which can probably probe a difference in non-clinical and clinical voice hearing within the context of prediction and attention. So that was our one motivation. That was our main motivation, to see and probe differences between the groups within the proneness continuum.
Yeah, so thank you for your answer, which is also very clear, right? So maybe related to that, or also at the methodological level, I was also wondering what was the motivation also to choose anger as a negative emotion to begin with, right? And also in chapter 5, if I'm not mistaken, I remember well, you also used happy voice, or what you call like pleasant voice. But as you may know, right, in positive psychology or positive emotion psychology, there are actually quite a lot of debates about what is actually pleasant or what is happy. Is it like relaxed? Is it like rewarding? Is it like relief? So there are many possibilities when we also speak and have a happy voice, which can correspond to different emotional content. So I was wondering then in your thesis, what kind of like pleasant voice you were after, and also related to what I said before, why did you select anger as a negative emotion to begin with?
For both, so for all the self-voice stimuli, the vocalization was 500 millisecond, which is a very short duration to encapsulate an emotion. And we tried a couple of pilot studies in the lab and also with the participants. We realized that within 500 millisecond, a negative emotion, for example, anger, was more precise and more clearly recognized when you hear your own anger voice compared to when you hear your own fearful voice and pain voice. When you hear it back again, it was not easily recognizable as compared to anger. And since anger is also a relevant emotion for within the context of voice hearing, we circle down anger as our negative emotion within chapter 4. For pleasure, we were looking for a positive emotion, and we had laughter as well as an emotion for positive aspect. However, pleasure emotion or pleasure or o vocalizations were easy to morph and recognize in terms of when you're presenting the 5 different types of vocalizations. That was one reason. Laughter or other happy emotions were not so much recognizable by the participants when we did the pilot studies. So that was one reason we went with pleasure and anger as our emotions for both chapters.
All right, yeah. Interesting, yes. And yeah, then maybe I can ask you a more general question to end my opposition. So I would like to ask you about this shift in your thesis between chapter 2 and the remaining chapter, right? Because in chapter 2, which you didn't really like highlight today in your presentation, was about conflict, about imaging, right? And then you gave that up in your thesis to some extent to move to auditory cognition and use this nice task you have mostly focused on. But I was wondering, why did you sort of like, did this change or shift in terms of methods and also topic? And yeah, what was the reason behind that?
For the short talk, I wanted to present a coherent story, and the story was a bit wobbly by including the first chapter. And I was not able to finish within 15 minutes by giving more explanations of all the chapters in the background. That is one reason that I stuck to the stories of chapter 4 to 6. Chapter 2, which is the fMRI study, where we see difference effect of emotional valence on cognitive conflict, was part of my master's thesis that went on to the first year of PhD. However, we changed gears from then on to voice hearing and sensory prediction and attention. However, there was also a common thread that was going on these chapters. So it was also a nice collection of chapters and research related to attentional control, prediction, emotion, that brings everything together. So yeah, that was a reason for shifting gears.
All right. Thank you. My time is over. I give the floor back to the Vice Rector. Thank you.
Thank you very much. The opposition will now be continued by Dr. van der Ven, Associate Professor of Cognitive Neuroscience at Maastricht University and also member of the Assessment Committee.
Thank you. Dear candidate, I read your thesis with a lot of interest. I started my own PhD on a very similar topic. I don't know if you know, but so I've shifted gears also in the meantime to other things, but it's still something that I still very much enjoy reading on. I had a few questions prepared. I'll stick to two, and I'll start with the one on emotions. Particularly, I noticed in your presentation that you had a nice example of how different emotions can affect your perception, and that particularly schizophrenia patients, when they hear their phantom voices, as you call them, are particularly bothered by negative emotions. And in your thesis, you've studied this in chapter 4 with negative emotions, but also in chapter 5 with positive emotions. It's also known that one could classify, let's say, some people as schizophrenia patients, even though they're not in the clinic, as they seem to report hallucinations that are not derogatory or negative, but actually are positive, or at least that has been claimed that some hallucinations are actually pleasant or supportive. I was wondering if your results are in any way representative of, let's say, positive emotions in schizophrenia, or if perhaps the null finding that you have in chapter 5 would indicate that perhaps positive emotions are really different from the negative emotions that we see in the typical clinical cases of schizophrenia.
Highly esteemed opponent, thank you for your compliments and questions. Indeed, for one, we did not have any non-clinical voice hearers per se in our sample for chapter 4, chapter 5, or chapter 6. So our results are not, our results are basically for non-voice hearers who vary in their hallucination proneness. But future studies should look into equal representation of non-voice hearers who are varying in hallucination proneness, but also non-clinical voice hearers and clinical voice hearers. Non-clinical voice hearers and clinical voice hearers. That is one. In terms of positive emotion, I think, again, future studies should take into account different positive emotions. We chose pleasure as an emotion here, which may have led to certain, in retrospect, certain issues in the sense that the null findings could be a result of an ambiguous context when a neutral voice is heard with 4 other voices with different amount of pleasure in them. So when you're hearing 5 different types of voices within a span of 8 minutes per run, you don't perceive neutral as much different from the positive or the pleasure voice in this case. So that could be a reason we did not see either an effect of completely neutral or completely pleasure emotion in self-voice. Again, pleasurable voice or pleasure emotion, when we were recording, the intensity of this particular voice was similar to neutral voices, which also has shown, which means that previous studies have shown that it takes longer time for emotions with lower intensity, for example, to process. And this could be another reason that we did not see differences between the different types of voices within this paradigm.
Okay, that makes sense. I would like to go now to a more cognitive question. or perhaps neuroscientific question, which is related to your description of the findings as being sensory suppression or suppression overall. And from the EEG topography in the N100 and in some studies also the N200, it's largely centrally frontal or frontal-central. But as far as I understood the idea of sensory suppression, it should also include the sensory systems. Particularly the idea of self-monitoring is, on the one hand, the expression or forward model of an intended act to speak, which does or does not map onto the sensory feedback of hearing yourself speak or hearing the consequences of your speaking. So the matching between intention and actual experience would then play out, I guess, in sensory cortex. Right? Or do you disagree?
Yeah.
No? Okay. So in how far do you think your effect of a less sensory suppression in more hallucination-prone individuals includes the sensory component? Because as it is more frontal-central, you could argue it is error processing of the ACC, for example, or some sort of level of surprise or attention, which doesn't necessarily need a sensory component to it.
Indeed. In my opinion, with the analysis and the ERP analysis that we did, I think it would be a far-fetched interpretation to go into different brain regions just based on the topography. If we had in combination, for example, analysis that depends also on the MRI scan, combination with EEG data, perhaps we could speak a bit more about where this is coming from and can differentiate which stimuli within this prediction paradigm is causing maybe minute differences between the topographies or the ERPs, and that could have probably answered the question. But with the current analysis, I wouldn't be confident in saying what brain regions, apart from the ones that are associated with the theories, we could state.
Okay. Is there time left, or should I leave it at this?
It's better if we can continue.
Good, yes. Thank you so much.
Thank you very much. The opposition will be continued by Dr. Goossens, Assistant Professor at the Department of Psychiatry and Neuropsychology at Maastricht University.
Thanks. Dear candidate, first of all, just like the rest of my colleagues and members of the Corona, I would like to congratulate you and your supervision team, your PhD team, with the accomplished work. And also congratulations with the nice overview you gave in the beginning of this defense. So in your thesis, you aim to systematically explore how changes in predictive processing and attentional control may be associated with phantom voice hearing as a function of hallucination proneness. That's how you state it. And like many of the others today, it's also this prediction processing that particularly piqued my interest. And concerning this, I have two methodological questions. First, I would like to ask you, what were the instructions you gave the participants for the task? Were they aware that you would use their pre-recordings, or were there any specific instructions? Because I can imagine that this also influenced their expectation and hence predictions.
Highly esteemed opponent, thank you for your compliments and questions. Indeed, I completely agree that the instructions would have an effect on the results. They came for a voice recording session where we recorded the neutral and the emotional voices, and then on a different day, we performed the EEG experiments. And the important thing for us was that they recognized their own recorded voices. So we made sure that they heard their own certain voices, 100% neutral, 100% angry, before starting the EEG experiments as well. So they did not know that we would morph or manipulate the voices. They just knew that perhaps we would use these voices in the EEG experiments, whether it is 100% neutral, angry, or pleasure. And we made sure before starting the EEG experiments that they were sure that it was their voice. In case they said, and we didn't have a participant that did not recognize their own voice before the EEG experiments, that would also be interesting to see what happens there. But all of them recognized their 100% neutral, 100% angry, and 100% pleasure voice. But yeah,
But did you tell them that there could be different voices, or just said nothing like you could hear your own voice, but other voices as well, or?
No, we just said that you could hear one of these two voices while performing these the EG experiment. Okay. They were not told anything about the ambiguous voices.
Okay, good. And then you also state that you rate valence, arousal, and the perceived ownness. But am I correct that you didn't perform any analysis with these ratings further on?
Indeed. We looked into the correlation of hallucination proneness with the valence, arousal, and ownership, respectively, for the participants. However, we did not find any significant correlation or a pattern that would make sense. We also did correlation between N100 suppression effect and arousal ratings, valence ratings, and ownership ratings to see if there is a pattern that is coming up and that would have informed or supported the results that we get from the ERP as well. But we did not find any logical pattern to expand on any interpretation beyond that.
Did you have any expectations about this, any hypothesis?
So the reason that we had these ratings was to sort of confirm, even after the EG experiment was done, that participants did recognize their voice and did feel that the ambiguous voices were, to some extent, not their voice or less of their voice. However, based on what we saw was a bit contrary in the sense that they did recognize their voice. Also, the most ambiguous voices were on an average rated at 7, which is...
It's still quite high.
Yeah, they recognize their own most ambiguous voice as well. And that is another reason why in all these 3 chapters we don't find interaction of condition and emotion with ERP data.
Okay. Can I ask one more? And also related to this, so you state in different chapters where you use the same paradigm that there were some limitations then to the experimental paradigm. So the obvious question is, what would you change then if you would be able to redo it? Or would you maybe also extend to an fMRI paradigm that you can disentangle the different processes more into depth? Any thoughts?
Indeed. Chapter 4 and 5, there were quite some things that I would like to change. The more apparent one is the presence of the cue, of course, that there is a positivity for externally generated condition before the stimulus is presented. But for me, the more important thing was that after the cue was presented for externally generated condition, the stimuli came exactly after 500 milliseconds, which means there was an expectation that was learned after a couple of times within the run. But this condition should be unpredictable. So I would, if I do this again, not only include a control condition, but also jitter the timing between the cue and the actual stimuli presentation for auditory only condition. On top of that, there is also a difference between the task design for chapter 4 and 5 and chapter 6, in the sense chapter 4 and 5 uses a completely random event-related condition, whereas chapter 6 is a block condition design. We also mix, for example, motor auditory and motor only condition with the same cue, which means that when the participant is seeing a horizontal cue and that they know that they have to press a button, sometimes they hear a voice and sometimes they don't. If it's a motor auditory condition, they do hear a voice, but if it's a motor only condition that is there, they don't hear a voice. Although the frequency of these two conditions was different and motor only was only 40 trials within the run. But there is a change in expectancy that one learns. And this could also be the reason, perhaps, for the difference in suppression effect in chapter 4 compared to chapter 6, where the difference is very clear. And So this is something that I would probably change. Remove the motor only from the event-related as well.
Okay, thank you. Give the word back to the project.
Thank you very much. The opposition will now be continued by Dr. Hausfeld. Assistant Professor in Department of Cognitive Neuroscience, Maastricht University.
Dear Proita, thank you. Dear candidate, dear son, also from my side, congratulations to you, to your supervisor team. It was a very nice thesis to read. I learned a lot because it is not exactly my field, the hallucination part there. So it was very, very interesting. And I also want to, I think that it is important to note that a lot of the things that you did here probably did happen during Corona lockdown. So considering the huge amount of participants that you have in your studies, this is quite something to be proud. But I also have to ask you a question. And I want to ask you the question which will be about chapters 4, 5, 6 mainly. Why do you make the effort to record the voices? And the reason I'm asking that is you are coming from a theory where you are talking about forward models, afferents, copies. When I push a button and I hear a voice afterwards, in my maybe naive mind, this does not send any afferents copy to the articulators or to any motor planning that is related to speech. So I press a button, yes, I expect that there will be a button press on my finger, but yes, and I might also in terms of timing expect that there is basically a voice appearing at some point, but I do not actively move my articulators, which results, maybe, as I said, in my naive mind, not in an afferents copy related to speech sound, at least from my own one.
Highly esteemed opponent, thank you for your compliments and questions. Indeed, the one reason that we did not do a talk-listen paradigm and we did this button press motor auditory paradigm was that talk-listen paradigm generates a lot of artifacts with EG, so that was one of the reasons. Secondly, the study was an extension of a previous study from our lab that used the same paradigm, and we were just adding one step more with emotions and morphing to sort of probe both prediction and attention. Previous studies have shown that both talk-listen paradigms as well as motor auditory paradigms where you press a button mimicking a motor act to produce a voice, you still see ownership and intendedness. And therefore you see suppression in the brain, not just with the EG signals, but also MRI studies have shown this. So yeah, that was another reason. But these are two different paradigms altogether, so yep. So
to wrap up there a bit, like, so that means that if I would ask you if I would use a random voice instead of the participant's own voice, I might receive, I might have different results. Also taking into account, like, if I talk now, right, and I play back what I say, I don't like my voice. I hate hearing myself from tape, right? And the reason is that the bone conduction that's not there, right? So basically, when we talk, we have the bone conduction, which means that our voice is nicely soft, basically nicely low frequency, right? So calming. But on tape, or CD or whatever, laptop, then it sounds rather shrill, right? So the question is how much ownership, might then still be attributed to the voice there.
Indeed, I completely agree that when we hear our own recorded voice, we don't like it. It sounds weird, but we still recognize that it is our voice. So there is less, but still ownership, perhaps, as compared to when we are talking. I lost my train of thought, sorry.
That's okay, that's okay. Thank you very much. I think that was a good answer. One thing that I wanted to ask about is you have this paradigm where you have basically this motor auditory condition and then a motor only condition, and you have a auditory only condition. Do you think it made an impact, also talking about predictions and keeping that in mind, that the probability of hearing a voice in the beginning is 33%, so rather surprising compared to a 50% chance that it might occur. So do you think that this might actually interfere with maybe earlier ERP components related to arousal and so on?
You mean within a run that the unexpectedness of a voice would grab more attention, perhaps compared to the later in the run of the same voice?
Yeah, so if you present a fixation cross,
yeah?
You have a 66% chance that you press a button and a 33% chance that a voice occurs, right?
Which chapter?
4, 5, 6.
Right, but in 4 and 5 there was a cue, a horizontal cue. If you see a horizontal cue, you press a button. Mm-hmm. You may or you may not hear a voice. But if it's a vertical cue, you just sit back and listen to the voice. You don't press a button.
Okay.
Whereas in chapter 6 there is no.
You may continue your sentence or not.
Right. In chapter 6, there is no cue present but a fixation cross, but participants are trained to press a button at a certain rate. Mm-hmm. And so it is under their control to press a button and listen to their voice, but it is blocked. So the first block, 4 minutes, is press a button at your own learned rate. And in the second condition, at the same time sequences, these voices will be presented back to you. So block second.
Thanks. Thank you.
Thank you very much. Xanthate Duggirala, the time appointed for defending your thesis has passed. The degree committee will now withdraw to discuss the quality of your thesis and your defense. I request that you and your company await the results of our deliberations and our return in this room.
The PhD defense has now ended. The degree committee will debate the candidate's performance behind closed doors. This process usually takes about 10 minutes.
Xanthate Duggirala, the degree committee here present has assessed the quality of your thesis and your defense. In view of its positive verdict and taking into account your previous qualifications, the degree committee has decided to grant you the degree of doctor. Professor Kotz is authorized to confer upon you this academic distinction in accordance with Dutch university custom. I invite your supervisor to now take the floor.
Please, all right.
Do you promise to work in accordance with the principles of scientific integrity at all times, to be careful and honest, transparent and independent, and responsible?
I promise.
By the authority vested in us by law and in conformity with the decision of the committee here present, I hereby confer upon you, I have a really hard time, let me say Duggirala, the degree of doctor and grant you all rights attached by custom and law. As evidence of this, I now present you with the degree certificate signed by the rector, the secretary, and other members of the committee, and affixed with the official seal of the university. Zan, oh, I should be using this. Dear Zan, dear Dr. Duggirala, this is the moment you have been waiting for. You did it, and all is well. Close your eyes for a second and feel this moment that you deserve so much. Today ends a long journey, and a new door opens in your scientific career or whatever comes next. Together with Anna, Michael, and David, I could not be prouder of you to have traveled this journey with you for such a beautiful end. This day is not only important for you, your family, your friends, but also for science. In the last few years, you've managed to dive deep into the human brain and its dynamics, used multiple methods skillfully, and revealed significant insights into the human capacity that can go so badly astray, voice hearing. This insight has raised so many new questions, and one way or another, I still have hopes that you will continue to answer at least some of them in the future. So let's take a short trip along Zan's journey. Zan, understanding that engineers can enlighten brain science and vice versa, first explored neuropsychology while still in India after finishing a bachelor and a master's in biomedical engineering. She then decided to come all the way to the Netherlands to start a research master's in clinical and cognitive neuroscience with a focus in neuropsychology in 2015. Zan was one of my very first students in the course Brain Damage, and since then we have traveled the worlds of FBN, FHML, Porto, and Lisbon together. And what a journey it has been. During this research master's, while a bit shy on the surface, you nevertheless started to show your true colors, or should I say feathers, soon enough, and became very motivated and excellent. Your energy and warm personality soon led to the doors of the band lab, and together with Lisa and Joe, the three musketeers of voice hearing science teamed up. You started your thesis together with me and Michelle, a postdoc at the time, on cognitive and affective control, piloting like a maniac to finesse the design of an fMRI study that you successfully published and a thesis that you finished cum laude. With not a lot of money in the bank at the time, I nevertheless could not let this rare bird fly away. So I approached you to find out if you would want to take on the challenge of a pre-PhD position to get a PhD rolling. And after some reflection, which is truly Zan's own personality, you took it upon yourself to take this challenge, and what a challenge it was indeed. Given your positive attitude, your caring ways, your dedication to the job, but to do it right, you flew through many storms along the way without losing ground. We became quite creative in knitting the financial support for your PhD together with Anna, then David, and then Anke. And I have to say, I never stopped to be amazed how you managed to sail so gracefully through the scientific sky, wherever the wind blew us, taking every bump along the way. I'm truly proud of you for all these takes-offs and landings that I know were not just a piece of cake. Even in the darkest moments of your personal life, you did not break down, you continued. In all these times, I always was confident that you will finish your PhD. You worked hard, with a clear mind, organized, with a long breath, knowing that breaks are important, and so are dear friends that remind you of them. You have it in you, Zan, so never forget that wherever you go next. In these seminal years, we teamed up as the Band Lab and other members of FBN, FHML, and the Voice Lab in Lisbon. We came to understand that teams achieve a lot, much more than individuals, and science is fun because we're teaming up. Zan, you are smart, organized, kind, and caring, and a wicked cook. Never forget this when the future is not always blue skies. I know you will fly high, and while I might not like to see you fly away, there's always a place for you to land again. Sorry. I'm proud of you, and now celebrate your achievements with your families and friends. You deserve it.
Dear Dr. Duggirala, also on behalf of Maastricht University, and I congratulate you with the degree you have acquired. The ceremony will now be closed, but before that I will explain that we stay here to take a picture of the candidate with the committee also on the screen. And you are asked to slowly move your way to the refter, where there is drinks. And congratulations. In between, we will also take a picture on the before the stairs, on the stairs, and after that, you have the opportunity to congratulate the candidate. Thank you very much. I now close this session.
Recording stopped.
Supervisors next to the young doctor. Caroline, explain the degree, please.
Yes.
Please come and join.